Hello, ladies and gentlemen. Welcome to the DP Labs channel. Today we will continue our experiment with plastic casting. The fig plastic has arrived, so now we'll be testing it. And we'll also try to show you chemical polishing of aluminum, if it works out. So, shall we get started? So what do we have? We've done some testing. What did we do here? We lowered this a little bit. Didn't we actually raise the heater itself?
Yeah, that's right.
Right here, so it would push all the way through. Stas, where are our pieces? What did we end up with? Here they are. Come on, show me. Wait, did we try different plastics here? The quality seems pretty good. This one, even polypropylene. Did we try that too? This is
Like a rubbery material. We have this one, what's it called? I forgot. Yeah.
Yeah, it's flexible and soft like that. We took this filament from a 3D printer. Now we've bought PEEK. Here it is. We're going to try it now. Because it's pretty expensive. How much is it? I don't know. 250 grams for 5,000 rubles. A kilogram is 8,000. I need to check. To make absolutely sure that it pours properly, we carefully sealed 3 different forms in the mold with these sturdy rubber bands, and we will pour just one of them. His temperature, as we have read, is 345 degrees, but we'll try to press it at 350 degrees. Well, I sincerely hope it works out, because it's quite expensive to experiment with this material. We really want to avoid wasting any resources, so we are being extra careful during this process. Let's fall asleep for just a moment.
Wait, what? Can you repeat that, please?
Didn't it all run away?
This is already...
Special tool. Did it help? It sure stinks, though, I have to say.
Where did you say? Could you please repeat that for me?
It fill up completely. It's unclear.
What, well, can you clarify that for me?
What are we waiting for?
Let's just wait. It'll catch up in a moment, perhaps. Our heating zone is set up like this here, so we filled it up completely, and because of that, it can't really push everything all the way out to the end, so we need to use only the heating zone.
By the way, you managed to cast 4 pieces, right? You set it up, yeah? Yeah.
These 4 were being cast. Likewise, these sets of 4 were being cast.
So let me get this straight. As I understand it, you actually made these risers in parallel, right?
The risers, yes, we changed them even before the video came out. That is the very next day after we did it. Why was the idea to have the riser go up? Well, the reason is that we wanted the part to stay on the punch, not in the die, since prying it out of the die is, well, really not ideal. You could easily break it.
Yeah.
Right. It was our first time doing this, and I thought, let's put the risers here. And again, the part was supposed to stay here like this during removal, because they would come out over there. But as practice showed, that was completely the wrong way to do it. We just blocked them off with a kick insert, and then we carefully made slots for the chamfering tools. And that turned out to be more than enough for the risers. And now everything comes off without breaking the corners on the parts. Because with the first ones we had, those risers would break the parts off.
So, shall we try it? Maybe right now, if you are ready? What do you think?
Oh, and we changed the configuration slightly, and made the bushings conical in shape as part of the update.
You resharpened them?
Yes, now they're conical, and now there are no problems at all, everything comes out perfectly. Well...
Super. By the way, did the mold warp at all? Well, there's no heat in it, it doesn't get hot. Look, we've got some kind of stringy bit coming out. How many grams do we have for this particular item? It probably weighs about 10 grams, right? Or maybe 5 grams. This one right here. What do you think? I wonder if we should check the weight to be sure.
This one?
Yeah. 4?
It weighs 4 grams. But again, the specific weight of plastics varies, but we weighed the one made with FMD printing, it's printed, and it weighs 4 grams. So we based our calculations on 4 parts and 16 grams plus a bit extra for the sprue. So that should be enough for 4 parts of the device. Well, you know, it's actually enough. These are really enough. These are enough. Let's see how it goes now. Well,
go ahead.
Temperature is actually much higher, in fact. Will it really be able to heat something this bulky after all? Well, let me think for a moment.
Go ahead. The resin is splattering a little bit. At least it's not throwing it everywhere.
It's pressing it down. And
did it press it all the way in?
Yeah, the cylinder just stopped now. Let's just hope that it's enough. And
Do you hold it under pressure for a while?
yes, we do keep it under pressure because I've noticed that some plastics shrink. So in future mold calculations, we'll take this into account so that these massive parts, well, the corners, are positioned at the gate. So when we press it in, it's so that, like with aluminum, as it cools, it draws material from there, so there aren't any little sink marks.
This?
Not all plastics, but many plastics do shrink. You can actually see the shrinkage here as well.
I see. Did it cool down like that, perhaps? Because we already pressed it out earlier?
Well, that's because fresh plastic came in there, which doesn't heat up this area, and it took some of it for itself.
It's someone's...
This plastic is very hard, Pet. I think they make teeth out of it.
teeth?
Yes.
Now,
Let's open it.
well, let me see.
We'll have to carefully add the back of the head, just as we usually do with our favorites.
Let's go. Let's move. Let's take it apart. Let's take it apart now. Let's take it apart together. Oh, well, from the outside.
It looks good from the outside.
And what's left on that one? Well, come on somehow.
The reason I want to master chemical polishing is so that our mold will be highly mirror-like in appearance. And this part will be...
Still rough.
It's still the inside, and the front part will be very smooth and won't hinder the process either. Well,
Go ahead.
without breaking it, without causing any damage or harm, without breaking it, we can carefully and gently unscrew the pins. I've already practiced this several times.
It's a pain, of course, but let's do it for this. So what are we going to polish chemically for the test? And
We have special test blanks, which we can also use to carefully check and verify the thickness. They're specially milled test pieces for us to closely monitor and measure the thickness of the anodizing layer. Yeah,
no, we should also use something real at the same time. Yeah, why would we check the thickness here? Oh, it popped out. The quality.
of the surface, of course, is so-so. Alright, we'll get it out with our fingers later.
Well, kind of. What's that dirt left there? Probably from the old ones.
Yeah, most likely. There's still probably some left on the walls. Yeah, it got a bit mixed in there. Well,
It looks fine. It'll do for our purposes. The dirt will come off. It's just, yeah, with the prying out. One moment. Well, the main thing is it pours. Can you pry it out?
yeah, I think we'll get it out now. Now we'll screw on the paddles. Let's try. Or let's go scratch it.
Oh, it came out.
The main thing is, well, you know, actually, let me just say,
It doesn't damage anything.
the spot where it's pouring out here is actually the thinnest part of the piece. Basically, that's a design flaw. You should pour into the thicker sections instead. That way there won't be any sink marks or shrinkage. But this is our very first mold, so we'll take all this into account. Now, after the test, we'll rework it.
Probably for the production run, so we don't mess it up.
And how is it?
In terms of rigidity,
As for rigidity, I think it's very hard because it was obvious when we were taking it off the injection molding machine. We actually couldn't tear it off by hand. It's really tough. No, it didn't break.
but it didn't get a proper glassy finish. The plastic is good, just expensive. And it needs to be polished to look nice. Even though it's all inside, we still need to achieve quality. But I already like it.
Yeah? Yeah. And the appearance still needs to be adjusted with the temperature, I think. We could try playing around with the temperature. Because on some parts, you can clearly see where the temperature was just right. They look really high quality. But with the polypropylene we have there, you can see that the temperature was just a bit too low. Well,
All right, we'll test it out. Well, we've understood all the mistakes. We'll fix them. These rubber parts are cool.
Plex. By the way, this was torn off. This is Plex. I remembered, that's what the plastic is called. Yeah,
Not bad at all, not bad. And it actually flows well, you know, right?
Yes, its flowability is very high. We can even post a photo in the chat later showing where it leaked. Really, the flowability is extremely high.
That's how it is. Well, that's it, folks. I think it's already better. We've understood all the mistakes. We'll rework the mold. We'll keep testing it further to ensure everything is functioning properly. And now we'll proceed to chemical polishing. So, gentlemen, let's try the chemical etching of aluminum. Not etching, but polishing. And what's the composition, by the way? By the way, yes, everything is in order here. A chemical fume hood, there's even a stir. What are we mixing with what?
It's phosphoric acid, nitric acid, and acetic acid.
And in what proportion? Could you please clarify for me?
Our phosphoric acid is 65%, nitric acid is 25%, and acetic acid is 10%. But we recalculated, since our phosphoric acid is 85% and 70%, we converted it to 100%. And so
we recalculated. All right, go ahead, pour it. I have a feeling it won't be smelly, but it's going to be epic. Oh, what are you doing there?
I pressed it. Yes.
Of course, the reagent consumption here is high. We should try the electrochemical method, but I'll test it out soon. We'll actually be trying to etch these molds later on anyway.
So we finally ended up with approximately 600 milliliters of phosphoric acid. Now we have 150 milliliters of nitric acid. And well, so
this is some crazy stuff. And well, you know, let me see.
We end up with exactly 100 milliliters of 70% vinegar.
Stir it. Shouldn't we heat it up?
Yes, we should heat it, but today we'll heat it a bit less than yesterday. The reaction is very vigorous. And
did someone forget to stir it?
I think it'll probably dissolve on its own eventually now, soon. Now we need to carefully etch the hydroxides, clarify the sockets thoroughly, and then come back here to finish up.
Did you bring the test plates for measuring thickness, maybe?
I brought 2 identical parts. We can actually measure the holes here. They're absolutely identical. This one's from the scooter, and here are our samples from yesterday as well.
Here's one that's been polished. Yeah.
One was done in a minute, and we lowered the temperature a bit. And the second one, as it said, was kept for 40 minutes, but it got eaten away. We kept it for 10 minutes, and the result was already unsatisfactory. Well,
so we'll keep it for a minute, right?
Yeah, we'll keep it for a minute and
show it compared to these. Can you see it? Can't see it? Well, you can see it, yeah. It's really shiny. There you go. Well,
there's one good light over there.
Yeah, I think if it was after tumbling, it would be perfect. Oh, by the way, we bought a tumbler.
We bought it, but we haven't bought the media yet. There are different types of media too. There are liquid ones as well.
For this activity, we'll try tumbling too. So, shall we go etch it? Yeah.
We're etching
in a sodium hydroxide solution, such as this one.
Yes, 2 minutes.
2 minutes. That's it. It's anodizing. It's anodizing. We're more or less matching the color. Here are some black nuts like this. It's working. Oh man, from the hydroxide. All right, I won't close the lid. It stinks really bad. Let's take it out. Where are we going? Oh, we need to rinse it thoroughly first. And then after rinsing, we want to brighten it up so it looks even better. Yes, that's right.
Then brighten it up again, just the same way. Just like before. And the anodizing is just as even. The hydroxide is already pretty weak now.
Yeah, it definitely needs to be disposed of properly. And here we just give it a little rinse, just a quick rinse to make sure it's clean. Yeah.
Just brighten it up. The nitric acid almost immediately removes it, and...
Is it the nitric acid that smells so strong? It gives off a little something. It's probably the nitrogen dioxide that smells a bit. Water again.
Yeah, rinse it again. Yeah.
By the way, the pH of this dye is really important during anodizing. Otherwise, it wouldn't take the color before. We set the right pH. And then everything worked fine.
Alright, now we can... What do they look like now? Are you sure it's etching? Yeah,
It's weak.
etching actually. So we've removed, so to speak, the oils, you know. Yeah.
Well, let's go. Stars promised it would be epic. I've never seen it live.
It'll heat up, we'll set it just a bit. The temperature is fluctuating at the moment. So,
How much do we need?
although it says 90 to 95, we probably will not actually heat it above 80. And now at this point, let us move forward together.
How much is it? I don't see anything.
Right now, at this moment, it's exactly and precisely 50 o'clock.
All right, we'll wait.
95. That's a lot. Yeah, it was like that yesterday. Let's turn off the heat now.
Stir it.
Like yesterday, we'll hold it for a minute. It will be like yesterday for us. We can't heat it anymore. We can even heat it from below. Yeah.
All right, but at least put it nearby. Yeah.
I think this reaction also releases heat as a result. Yep.
Well, here we go. All right then.
Yeah.
Oh, it's bubbling. Oh my god. Oh my god. Oh my god. This is just absolutely awful. Oh my god, I can't believe it. This is really, really bad. Oh my god.
Yeah.
Doing this without a fume hood is pretty sketchy.
The glass is filling up quickly. So
Should we maybe hold the other two for just a little bit longer for now?
now at this very moment, we find ourselves right here, focusing our attention on this particular place and time.
There's no smell at all. Just a regular kettle.
Oh, well, I see. Let me think.
Look how black it is.
Well then, that's it.
In my opinion, I think it's overall significantly better and more comfortable afterwards.
With your hands. In just a minute, you can already see, for example,
The difference between the two values,
already.
yeah, not bad. After tumbling, it was absolutely perfect. Well, you know, Stars says the reagent consumption is actually high.
Yeah, it says it's about 6 to 18 decibels per liter of this particular solution, you know?
Yeah, you'll go broke that way.
But if you need to polish something in a place where you can't get to it mechanically, it's not a bad option. So our time is 1 month.
Yeah, go ahead.
Let's hold it a little longer.
Yeah, some lithium forms are actually really fine. Yeah, it's not clear what kind of reaction is going on there. Such a chemical mix. All right, so here we remain waiting for 2 minutes. Okay, we'll get back to you. Oh my god, just like, I mean, it's really just brownish brown gas. He condensed the material back once again from the paraffin. Such as this, for example, in situations like this.
So heavy that I'm not even ready to lift it.
Yes. How creepy. How much did he eat there in total exactly in a minute?
There are exactly 3 tens in 10 minutes in total.
Oh wow, just... Okay, that's it. Let's get it out now. Oh my god, I can't believe this is actually happening. I feel so nervous and excited, but we need to be careful and take our time as we do this. Come on, Kunai.
Now we will carefully and slowly remove this dark dot in a solution of nitric acid and
Let's see what happens.
alright, okay then, well let me see.
You just need to dip it a little, right?
Yeah, just to basically remove the oxidation.
All right, I can't see a thing.
We need a part that's recently just been milled for comparison, then it'll be visible.
Well, let me see. You know, well...
Well, basically, you know, in essence,
It's shiny. Believe me.
Even the marks from the vise are barely visible now.
Yeah, it got etched. You can use it, but typically the consumption is high. We'll try the electrochemical method soon, maybe next week. Here it's kind of strange. It only cleaned part of it. Oh no, that's it. Oh, there it is. It's shiny. And we'll run the tumbling process. And after that, we'll try again. I think it should shine like a cat's balls. Well, you know, that's just how it is, I guess. Hope it was interesting. So subscribe to the channel and give it a like. See you soon.